So let's have a look at this question here. We're on the Confluent community Slack, and Deepesh says, is it possible to put the Kafka offset and Kafka partition as part of the message when we're writing to the S3 sync? So let's have a look at how we're going to do that. First up, let's get ourselves a Docker Compose, and this is what I'm going to use for building on. It's just a very simple one. We've got Zookeeper, we've got the Kafka broker, we've got schema registry, and then here's Kafka Connect. So I'm using the Kafka Connect base image, exposing port 8083, bunch of config here, and then down here we're going to use a little hack as part of the command. When we bring the container up, we're going to get it to install the particular connectors that we need. So in this example, I'm going to show getting data from Kafka into S3. We're going to answer the original question of can you get the partition and so on as part of the message, and we're going to see how we can try and do that. And I'm going to take data from a new connector called Voluble, which lets us generate cool test data. So let's go and find these connectors. These connectors are over on Confluent Hub. So if we go to Confluent Hub, and there, and here we can search for S3. We're going to use Kafka Connect S3 here. And so this is the install statement. Here's the name of the particular connector. So we'll copy that, head over to our Docker Compose, and stick that in there. And then we'll do the same thing for Voluble. So that's been recently added as Voluble. So Voluble, you could use Kafka Connect Data Gen as well, but I want an excuse to try out this particular connector. So we stick that there. So all that we're doing here is we're saying use the base image for Kafka Connect, and we want to install a couple of connectors, because you have to install the connector, you have to install the jar before the worker starts up. So if we just created the container and then tried to install the stuff, that wouldn't work, because you need to restart the worker, and you restart the worker, it restarts the container, and it kind of gets messy. So here we're doing it by saying, well, override the startup of the image, and saying, well, we're going to run the original command, but before that we're going to install these. Another way to do it is to actually download the connectors, put them in an external folder, and that's also exposed within the container. So that would also work. So you put your connectors in the connectors folder locally, that one there locally, and then that gets mounted into the container as /containers, connectors, and that one there is also exposed within the container. But recap, within this particular container, Kafka Connect, we're using the base image. When the base image starts up, we're going to install a couple of connectors from Confluent Hub directly. They'll get installed into this path here, and so it's Kafka Connect. We set the plugin path to wherever we've got our particular plugins. The other container we've got is case=db. We don't have to use that, but I'm going to use it anyway because it's interesting to see what we can do with it in terms of managing Kafka Connect through a standard interface. So let's save that, and now let's bring it up. So we're over here. This is going to go into demo scene. So if you're not familiar with demo scene, let me just show you that. So here's demo scene. So demo scene is part of, it's a repository that we host. It's where all the demos go. So like the developer advocates and various Confluent staff put stuff on here. It's, as this thing says up here, it's rough around the edges. We don't QA it all, or rather we QA it for the particular talk that we're going to give. And then maybe it was from like 4 days ago and it's brand new and fresh. Maybe it's from a year ago, and maybe things have moved on since then. This is in contrast to the examples repository. So the examples repository is where stuff goes, and you've got the full end-to-end stuff, and it gets QA'd for every single release and stuff. So it kind of, they serve different purposes. Right, we've got our code in there. So now let's check we saved it first. Yeah, we did save it. So Docker Compose up, and that's not going to work. So the service depends on this service. So broker 01. So we're saying that depends on that, and I made a mistake when I did a search and replace. So that depends on Kafka Connect. Okay, let's try again. Okay, so now it's going to pull down the different components. So we've got the broker. This is 5.4.1, so the very latest of it. Obviously based on the latest distribution of Apache Kafka with some of the Confluent distribution around it. So Docker Compose PS, and we can see here, interesting, case=db is bombed out. We're not using that right now, so let's ignore that for now. We can see that Kafka Connect is starting up, and if we do a Docker Compose logs follow on Kafka Connect, pipe that into more. We can see that as it starts up, you can see the first thing it does is it installs these connectors. So we can see it's installed this particular S3 connector, it's installing the Voluble connector, and now it's actually launching the actual Kafka Connect worker. So let's come out of that and just stream the log so we can see it all starting up. Interesting. So no resolvable bootstrap URLs given in the bootstrap servers. So we've made a configuration error. This Docker Compose, I was hacking around from some other stuff, so let's go back and have a look at it. So no resolvable bootstrap URLs is kind of like the problem which has caused this root issue here. So failed to create a new Kafka admin client. Let's go and have a look at what's going on. So our broker is on a machine called broker. And our listeners here, we've got two listeners. We've got one called one for the internal Docker network. So using the host name 29092, and then here's one that you can use externally from like the Docker host. That's the second one. And down here in Kafka Connect, we've said my bootstrap servers are called Kafka, and it's not called Kafka, it's called broker. So let's change that, and let's cancel that and bring it back up again. So Docker Compose up-d Kafka Connect. Whilst that's doing, let's go and see if we made a similar error in the KSQLDB, and we did. So let's change that. So the bootstrap servers is where KSQLDB or Kafka Connect previously are going to connect for the Kafka cluster, and we'd set it up wrong. So let's set it up right. We've done that. So recreating that, let's bring up KSQLDB as well. Okay, let's go and check the logs for Kafka Connect. Okay, so it's downloading the stuff. Okay, so that's Kafka Connect brought up. We can cancel out the logs there because we were just following it. And if we do Docker Compose PS, we can see everything's up and it's running. We've even got a health check there for Kafka Connect, which shows that it's healthy. So now we're going to create a source for our data. And we've got this plugin that we installed called Voluble. Let me just go and show you that on Confluent Hub. So it generates streams of realistic data. We've got some documentation over here. So let's click through to that documentation. And that's going to let us create the connector. So here's an example. Let's just take it as it is from the README because these things usually work. And you'll notice here it's saying create source connector. That's because we're going to do this through KSQLDB. Now, KSQLDB works with Kafka. It reads data from Kafka, it writes data to Kafka. KSQLDB also interfaces with Kafka Connect, and you can run Kafka Connect within KSQLDB. You can run Kafka Connect as a separate worker process. But the cool thing is you can use KSQLDB as a way of creating and managing your connectors. So we're going to use KSQLDB. You could take this and just run it as a standard REST call to the Kafka Connect REST API. You could do it from Confluent Control Center. However you create and manage your connectors, you can do it through that. Here, I'm just going to use it through KSQLDB. So let's bring ourselves up a KSQLDB session. So we're going to run that from within the Docker container. So we've got a Docker container here for KSQLDB, and that's running both the server and it has a CLI available within it. So we do a docker exec, run within this particular container, a KSQL command connecting to this server. So we're on KSQLDB, show topics, let's have a poke around, see what's going on. We've just got the processing log, an internal topic at the moment. So now let's see if this is actually going to work, pasting literally the thing from the README. So we paste that into there, create a source connector S, somewhat elusive. And we're saying the connector class is this voluble source connector, and it's going to create us some data. So create connector, show connectors, has it worked? It has. It says it's running. There's one task out of one available tasks running. And if we say show topics, there we go, we've got some data. And if we print those topics, so I've not actually run this before trying it, so it's kind of cool that it's working first time, print adopters, and there's our live stream of data coming through. And show topics again, print diets, and you get more data there. And if I just say print diets, limit 5, there's just the first 5. So you can see something quite nice here. This isn't supposed to be a KSQLDB demo, but it's turning into it. One thing it's doing is it's saying, I'm going to go to this topic and I'm going to guess at what the serialization is. So it says the key looks like it's a string, so the Kafka serialization. The value is Avro. So we've got the schema registry, it deserializes the data, and it shows it here. So this is kind of cool. So now what we're going to do is we're going to push this data. So let's have a look at the topics. Pick one of those topics. We've got cats, we've got owners, diets, and adopters. Let's take the cats one. Print cats. We're going to stream that information about the cats and their owners, and we're going to go and stick that into S3, and then we're going to answer the original question that prompted all of this, which, let us remind ourselves, is it possible to put the Kafka offset and the partition as part of the message that we're going to write to S3? So let's figure that bit out next. First thing we should do is go and check the documentation, which of course is what everyone always does when presented with a problem. So here we've got a link to the docs. That's for 4.1.0, which is kind of old. So I'm going to go to the most recent version here, which is this one up here, /current. And we can see at the top, it says, before you begin, create an S3 destination bucket with write access. We're also going to need to create ourselves some credentials to access it. So you could do this through the CLI. You can do it through the S3 web interface. I'll do it through the CLI because it's kind of quicker. So S3 MV make bucket. I'm going to create one here called armoff voluble test. So created that, and now let's also create ourselves an access key. So you could use existing ones. I'm going to create a new one because I'm going to show you them, and then I'm going to make sure I can trash them afterwards. So for that one here, I've got it on my clipboard, my search back, and this is the IAM. So delete list access keys, create access key. So this is going to create as a brand new access key pair. This is obviously the point of keys, that you just have key pairs that you can use and then get rid of, rather than just like one password, which if you want to give revoke access, you then revoke access to everyone. So here's our access key. Access key, this one here, and secret access key. So those are the bits that we're going to need, and you'll see it's active. So now let's go and put those into a file. So if we go back to the docs, we can see down here, and in the docs it says S3 connector credentials, and there are 3 different ways that we can actually specify the credentials. So we could set it as environment variables, you can put it as system properties, or you can put it as a flat file. So I'm using Docker. I could probably set it as environment variables, maybe we'll try that afterwards, but the way that I definitely do know works is by putting it into a file, which we then mount into the Kafka Connect container. So our file is going to look like this. So over here, we've got one that I created earlier. So there's our outline. And here's our credentials, so let's paste those. There's our access key. Here is our secret key. Okay, let's do that. And then we're going to go and save that over up here, Kafka to S3. And we'll save that simply as AWS _credentials. Right, so there's our credentials. And now what we're going to do is we're going to mount that into our Connect worker. So here's my Docker Compose. Let's close these other ones to avoid any confusion. Don't save. And over here, Kafka Connect. So what we're going to do is we've got volumes where we're mounting optionally external connectors, and now we're saying in the current working directory, we've got a file called AWS credentials, and I would like to mount that into root.aws credentials. So when the Docker container runs, it runs under the user of root. And if we go back to the documentation says it needs to be in, so tilde is the user's home folder. So if it's root, the user's root, then it's /root.aws/credentials. So that matches that. Right, so if we now go back to here and do Docker Compose upd Kafka Connect, it should recognize the Docker Compose has changed. So it's going to, as it says here, it's recreating the container, which means that I'll have to pull down those the 2 connectors again. So obviously you can see there are pros and cons to doing this. So this is really handy when you're just mucking around in a sandbox and you're spinning things up and you want to install things and kind of just see what works. If you're actually set on which connectors you're going to use, then you'd probably pull those down and stick the jar into a local folder, which is then mounted into the container. And you wouldn't do this each time because it's going to be going up to the network each time. If you're on like an air-gapped machine, obviously it won't work at all. So Docker Compose logs Kafka Connect. Okay, so this is why it's tedious, because it's now got to pull it down each time. I'm on a fairly slow internet connection. So they're getting pulled down. But when they've come down, then we're hopefully going to be able to create our S3 sync. So whilst that's spinning up, let's go and find ourselves some copy paste that we can use to do this. So what I'm going to do is I'm going to go to one which I know exists. So on demo scene, and this is the way that most people build things, isn't it? You find an example of what you want to do and you just copy and paste it and tweak it to your own one. So a while back I built an example of using rail data and pulling it in and building cool stuff with it. And as part of that, it got pushed out to S3. So it's kind of cool. It's like ActiveMQ and kind of wrangle it and stuff like that. And one of them was an S3 bucket. So I know that I've got a connector definition that I can copy here. So egress and S3, create sync. So let's copy ourselves this and go and put that into our editor. I'll set the mode to JSON. Okay, so we're going to do a REST call to Kafka Connect endpoint. So here we're going to run this on our local machine, so the Docker machine. And if we check in Docker Compose, we can see that the REST port for the worker is 8083, and we've exposed that to the host as 8083. So let's make sure that what we're going to run is going to work. So that's port 8083. The sync's going to be called S3. Let's call it voluble. Okay. And one thing to point out here is I'm doing a put against, instead of, most people do a post against the connector's endpoint. I do a put against the config endpoint with the connector name. The reason for that is you can run it once and it creates it. You can run it again and it updates it. Whereas if you do a post, you then have to delete it and do another post if you want to change it in place. And if I run this again, it'll just kind of like update the configuration. If there's nothing to change, it's not going to change it. So using a put is kind of like easier. S3 sync connector, the key converter is a string. Let's just check that's right. So if we go over to here, we're back in KSQL. Print cats, limit 5. Okay, key format is a string. All it shows here is a struct. So let's see how that actually is going to come through. The value format is Avro. So what we need to check here is, so let's talk about serializers and converters because they're kind of important. The key converter we're setting explicitly. If we go back to Docker Compose and look at the configuration for the worker, because these are kind of like global defaults, you can see that by default the worker is using Avro for its keys, so we need to override that because the source data has got the key as a string. But the connect worker is using Avro for the value, and that's correct because our source data that we can see in KSQLDB here is in Avro. So that means that we can just leave that as it is, and we don't need to specify it here in the connector. If it wasn't Avro, we would override that per connector. Unless all your data ever was JSON, and then you'd overwrite that as a global within the connect worker. So here's our connector definition. We've got the connector class, the key we're overriding, single task, the topic is called cats. Region, bucket name, so bucket name is voluble. And then the rest of it, S3 storage, the format class, we're going to write it in Avro, the schema generator, got this, and we've got that. Okay. So that's kind of set up. Let's go and check out the worker and make sure it's come up okay. So that looks like it's running. If we go back to KSQLDB, if we say print cats, we should see that there's like data still coming through. I don't know if my microphone is picking it up, but the fans on my laptop are whirring as well. So we've obviously got tons of data being generated all the time. Now what we're going to do is answer this question that prompted all of this. How do you get the offset and the partition as part of the message? So now let's talk about single message transforms. So single message transforms, part of Kafka Connect, and what they let you do is change the data as it passes through, either for a sync connector from Kafka out to the target, or a source connector from your source into Kafka. So you can do things like you can drop fields, you can change data types, you can change topic names, you can also insert data. So you can insert fixed data, like if you read from a source system, you could hard code like the server name that it came from. For a sync connector, we can start to insert things like bits of the Kafka metadata. So to do that, we're going to use single message transforms. So there's a couple of things let's have a look at. So there's one here. Let's see if I can find the link. If you wonder why I keep looking up and down, I've got two monitors and I've got a clipboard down here. So I'll put this in the notes that go with this video, but this blog here explains about single message transforms, and it shows them in action. And one of the ones that we're going to use is add metadata to the message. So I hadn't planned this in advance. It just so happens that we've got some of it there. We've not got all of it though. So if we remind ourselves, we want to get the offset and the partition. And so we've got the different transforms available. So we've got the transform types, which are insert field, and then you can see we've done a couple of different transforms, insert topic, and then insert source details. So insert field is the name of the single message transform that we're going to use. So let's go and look that up and see what we can do with it. So let's say Apache Kafka insert field transform. And we can see here insert field. So single message transforms were added into Kafka Connect or Apache Kafka, I think with the 0.10 release. I mean, like they've been around for ages. So insert field, we've got various different things we can do, and we've got different things we can add in. So we can add in the offset, and we can add in the partition, which let's just check is offset and partition. That's what we wanted. So offset field, partition field. So we're going to have two different transforms. And we're going to specify to insert those. So let's add those into our configuration. So transforms are a bit fiddly to set up, and there's no kind of like way around that. They are, but copy and paste goes a long way. So transforms, insert offset and insert partition. And the thing here with these are just labels. So I could call this kind of like Fred and Bob, but that would be kind of unhelpful. But the point is, you then have down here, you put your labels. So Fred has got a type, and then Fred would have the particular field against it. So the static field and the value. So we're going to need those, aren't we? Let's put those in. So here's Fred. We need some commas. This is why I'm using the syntax highlighting, because it helps me pick up mistakes as I go through. So the field that we're going to use here, this is going to be for Fred, so let's change that back to something sensible. Insert, let's say add offset metadata, and this one is going to be add partition metadata. So this is going to be the, let's say, underscore offset, and the value. Okay, so offset field, so the field name for that. So what we're saying here is, okay, so for each single message transform, you have the type. So dot type is where you specify the class, and there's the particular type that we're using. So this insert field value. So $value is because we're putting it into the value part of the message, not the key part of the message. And then you've got the properties. So one property that we saw in that example previously was static field and static.value. Let's forget that. That's got confusing. Offset field is what we want here. So this is the field name to write the offset to. So it's even simpler than that. So we don't need that one. We just need offset field. And then we can get rid of that. Change that. So there's offset. Okay, and partition. And here's partition field. Partition. So we're saying do two transforms. One of them is called add offset metadata, one of them is called add partition metadata. Add offset metadata, as we can see when I select it there, it shows us the configuration. So you prefix it with transforms because it's a transform, you prefix it with a label, and then you've got configuration elements. So you've got a type, which is insert field, and we're inserting the field into the value part of the message, so it's $value. And then we've got additional configuration, which is the offset field. So that's the bit that we got from the reference here, the documentation. So if you say offset field, that's the field name to which to write the Kafka offset. And the same thing with add partition metadata, insert field again, but this time we're saying write the partition field to partition. Now I'm going to run it like this. I wonder if actually we could just do it like that and run it as a single transform. I don't know if we can specify both. In fact, there's probably no reason why we can't. So let's try that. So let's say add metadata And that's, so insert data, and add metadata, the offset field and the partition. Oops. Okay, so we've got a single message transform. This is getting simpler. Right, now we can hopefully run it. So we've got our connector. Okay, there's our connector, it's running. Let's cancel that and let's remind ourselves what we did with the credentials. We took those credentials and we wrote them into a file in our local host folder called AWS credentials. So that file called AWS credentials, if we cat the file, you can see it's called AWS credentials, and there's our details. Obviously I'll be revoking these as soon as I've finished the recording, because that's kind of useful information. But we can also say, let's just check that that file is where it should be on the worker. So our worker is running under a container. We've used Docker Compose over here to actually mount that in. We've said when you run this particular container, Kafka Connect, mount this particular file into that path on the container. So we can say docker exec on Kafka Connect, do a list on the root.aws credentials, and it says there it is. So we can say, well, let's cat that, and it's there. So this is a useful way when you're mounting things in and out of containers to actually validate that it's doing what you think it's doing. So we can see that that's there. We've restarted the worker, so you always need to restart the worker. And now we can actually try this out. So let's copy our thing off our clipboard, and let's go and create our connector. So here's the other way of creating connectors, or here's another way of creating connectors. The first way, let's just switch back and remind ourselves of what we did. We did this. We said create source connector, and then we use KSQLDB as our KSQL prompt, KSQLDB as a wrapper to say go and create this connector against the Connect worker, whether that's embedded within KSQLDB or external. But Kafka Connect exposes a REST interface, and we're going to use that REST interface here simply to do a curl command to send our configuration to it. So we do that, and hopefully it says created, and it does. It says I've created it. But this is just Kafka Connect, and it's got a REST API. So we can do a couple of things. We could actually go back to KSQLDB. Oops, not rerun that because it exists already. But we can say show connectors. And it says you've got two connectors. One is called S, the elusive S, and one of them is called a sync. Okay, so when we say show connectors in KSQLDB, it's simply going to the worker that we've defined, and it says, tell me about the connectors you've got using the REST API. But here it's saying we've got a warning. Okay, so the demo was going so smoothly up until then, but this is what happens when you don't actually rehearse something beforehand and just see if it'll work. So let's go back here. The other way you can do it, if we find the appropriate sort command, it's hiding on my clipboard somewhere, so I'll duck away from the microphone again. And you can see this, and we paste that in there. So this is a little snippet that I always have on my clipboard, which goes to the actual REST endpoint. And there's our worker. Here's our REST endpoint. Recent versions Kafka, I think it was 2.3, added in this improved information, but you can get kind of like rudimentary stuff previously. And then we stick it through JQ and reformat it into something like this. So we've got a source and a sink. Our source is running. Our sink, the connector is running. The task is failed, which is why if we go look at KSQLDB, we get similar information. It's saying 0 tasks out of 1 are running, and therefore the overall status is a warning. So that's not so good. We've created a connector, the connector exists, but it's not running. The task has failed. So what we do now is we go to the logs. We could use the REST API to pull out the stack trace, but generally the logs are kind of easier. So logs-f. Okay, I'm using the bash Control R to scroll back through or to search back through the history. So because I've run this command before, I can just type logs-f and it comes up with that. And if I press Control R again, it kind of cycles through any other ones that I've run. So logs-f, Kafka Connect, and we can see through here, it's thrown an error. So the error is up here, but let's just point out something that's really important and catches some people. If you look at the error log, the error at the bottom that might catch your eye is error. Task is being killed and will not recover until manually restarted. That is simply like a symptom that something went bang. That's not the actual error itself. So whenever you see that, you then need to page up. So let's page up here, and we can actually see it on the screen. you can see the task started running and it went through here, and then the task threw an uncaught and recoverable exception. Here's our exception, non-existent S3 bucket. Okay, so we made a bit of a foobar in configuring it. So let's leave that log running and let's go back to our configuration. Our configuration over here, we called it armoff-vulnerable, but I think we called it armoff-vulnerable test. So now, because it's a put, I can simply copy that and let's paste it into a new pane here. Paste it into there, run that. It's going to create the connector again, or it's going to update the connector. And if we move that down here, we can see that the worker log up here is ticking on by. We've not seen any errors yet. We can see up here it says it's connected. And then here, another error. So this is why it's useful actually just leaving the log running, because we've got another error. So if we page up from that, it looks like another exception. Unable to initiate blah blah blah, and the bucket is in this region and you said it was somewhere else. So this is a good example of a really nice error message. Rather than just saying like no, it's actually saying, well, that you've specified the bucket does exist, but it's in a different region, which is really helpful. So now we can take that and we can go back to our configuration and say the region is actually different. Paste it into there, copy it onto the clipboard again, go back here, bring that pane up, paste it in, go down here and see what the log says. So we can see the task has started up again, it's ticking by, it's opening a writer, and this looks a bit more promising. So look at this, opening writer for here, and we've started to commit, files committed to S3. Okay, good stuff. So if we go back to KSQLDB, show connectors, and it's running. So this is a good example actually. I've not run any KSQLDB SQL, I'm not doing any of that kind of stuff at the moment. I'm simply using this as a wrapper for Kafka Connect. And writing show connectors is a heap easier than trying to remember like the REST call to make and then like the bash stuff that I had wrapped around it. So if we just close that, and I'll remind you, so with the REST call, I did this. I said I need to do a curl, and I need to pipe it through here to get it into any kind of format that's useful. And if I don't, it looks like this, which is useful for computers and it's no use for humans. So using KSQLDB, useful wrapper on top of Kafka Connect alone, even if you don't do any actual SQL stuff with it. So our connector is running, which is great. So now let's actually see if we've got data in there. So AWS 2, S3, list S3, armoff vulnerable test. Okay, we've got one called topics and cats. There's probably a quicker way to do this. You can see that it's partitioned it. And a slash on the end. Okay, so we've got data in there, and we've got Avro files. So now we need to figure out how to actually get the data out of those Avro files to understand if what we actually try to do at the beginning of all of this, which is get the offset and the partition into the message itself, is going to work. So what we're going to do is we're going to pull down one of these Avro files and then use a tool locally to inspect it. So I can use AWS S3, we're going to copy this particular file, just pick one of these ones here, and we'll copy that just locally. So that's hopefully downloading my lightning fast home connection, and we can list there, and we can see we've got an Avro file here, and then there's a tool called, appropriately enough, Avro cat. So we type in Avro cat. Okay, so Avro cat and cats, and we'll pipe it through JQ because the output's JSON. And if we pause that output, you can see we've now got the data that came from the topic, so our owner information, and we've got the partition, and we've got the offset. And you can see it's going through there. The partition's 0 all the time, because if you remember, if we cancel that and remind ourselves where we're at, it came from partition 0, because the data's partitioned, and the S3 connector, the way we set it up was to send the data by partition. So all of these are going to be partition 0, but they'll actually show the correct partition, which is 0 in this case. And then we've got the offset. So there you go. That's the answer to how you get data from Kafka out to S3 and using a single message transform to add in the offset and the partition information.